Good morning, everyone. This is Miss Barber. This is my first time doing a video like this, so please bear with me as I'm trying to figure this out. So I know that Miss Curie has worked with you guys on solving for y, getting y by itself in slope-intercept form, and then being able to graph those equations and finding the point of intersection, because the point of intersection in a system is the solution, okay, to the system. You also worked a couple of days ago on setting up equations from words in standard form where x and y are on the same side. And we're going to continue to work on that today, but instead of looking at just one equation in standard form, we're going to set up two equations in standard form. Okay, so let's take a look at our first problem here. It says the sum of two numbers is 20. Now, if you'll notice, that is one sentence. So that one sentence right there is actually going to be our first equation, okay? And then we have a second sentence. It says their difference is 4. So that means that that will be our second sentence. Now, it says to find the numbers. So that means that we're talking about two numbers. Right here it says find the sum of two numbers. So we'll have x represent the first number. Okay, and we will have y represent the second number because we have two unknowns, so we need two variables. Okay, so the first linear equation is going to be coming from our first sentence. Okay, it says the sum, and remember that the sum means to add of two numbers. Well, our two numbers are represented by x and y, so we're going to say x plus y is equal to, is means equal, so go ahead and put that on your paper, 20. All right, it's as simple as that. We're done with sentence 1. Equation 1. So let's move on to sentence 2, which is going to be equation 2. Okay, it says their difference is 4. Their difference. So if you remember, difference actually means to subtract. So the difference between the two numbers, which are x and y, represented by variables right now, is, and remember is means equals 4. Okay. We have two equations, we have two variables we now can solve, okay? So what you're going to need to do now is you're going to get y by itself. So we've been practicing this all week, okay? So I'm going to look down here and I want you to go ahead and circle y to keep in mind that we're trying to get y by itself so that we can then graph it, because our whole equation should be in slope-intercept form. Just a reminder that y is by itself, okay? So we are now going to subtract y, not subtract y because we want to get y by itself. We are going to subtract x from both sides. Okay, so we're going to subtract x here and we're going to subtract x here. Now, when we do x minus x, that's going to cancel out and give us 0. We're going to bring down this positive y here, so we can just write y, the equal sign. And because 20 and x are not the same, those are not like terms, we cannot put those together. So we're going to write 20 minus x. Another way you can write that is with the negative x first and the positive 20 behind it, okay? So now we have y by itself, and we can move on to our next equation, okay? The next equation also has x and y on the same side. Notice how I circled the y, but also the negative in front of it because it goes with the y. All right, so we're going to follow the same type of steps. Let me just pick another color here, and we are going to get y by itself, so we're going to subtract x from the left side, and of course we're going to do it from the right side as well. So that's going to cancel out our x's. We're going to be left with a negative y is equal to 4 minus x. Now we never leave x negative, so we don't want to leave y negative either. So that is, y is being multiplied by a negative 1. So to get rid of that, we are going to divide by a negative 1. So we're going to divide everything by a negative 1, and that's going to leave us with y is equal to 4 divided by negative 1 is negative 4, and a negative 1x divided by a negative 1 will yield a positive 1 over 1x, or just positive x. Okay, now we can rewrite that with x being in front if we want, but I'm running out of room, so I'm just going to put it like this for now. All right, now what you can do is you can graph this. Grab your graph paper and go ahead and graph it, okay? If not, you can always pull up your calculator if you have your calculator. Now, I'm not sure if Miss Curious showed you guys how to do this or not, but I'm going to show it to you right now, okay? If you go into your calculator, you are going to type those two equations into y equals. So if I pull up my calculator right now, okay, I got to clear out what I've got in y equals. So we're going to hit second plus 7, 1, 2. And that's going to clear our memory for us to get started with this problem. So second plus 712. All right, so now the memory is cleared. I'm going to go to y equals, and I'm going to type in those two equations. So the first equation was y is equal to, oh goodness, I forgot what it was. Let me grab that paper real quick because I already X'd it out. Bear with me, please, for just a second. So I believe it was y is equal to 20 minus x, or you might have negative x plus 20. Be sure that negative, if you type in negative x, that you use the negative underneath the 3 right here, okay? The x is right beside the alpha key. So you can either do 20 minus x, or you can clear that out, and you can do a negative, which is right below the 3. Put the x behind it, because that's the slope. And then we're going to add 20 to that. Okay, so then just remember, this is the y-intercept, 20, and your slope is negative, so that line's going to be going down from left to right. Okay, our second equation, we got it equal to y is equal to negative 4. So put in a negative before you do the 4. Okay, negative 4 plus x. Negative 4 plus x. Or you could rewrite that as x minus 4. So that means that your y-intercept is negative 4, and your slope is the coefficient of x, which is 1 over 1. So it should be a positive slope. Okay, so that line should be going up from left to right. Okay, so now we want to take a look at it. We're going to hit graph. Okay, and again, you can do this by hand. You know how to graph in slope-intercept form. And we are looking for the point of intersection. All right, so there's the negative 4 graphed with our slope of 1 over 1. And now we're waiting on it to graph, let's see, the 20. Oh, I don't see the second equation. Let's talk about why I don't see that equation has a y-intercept of plus 20. Well, if you look right here, this only goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a y-intercept of 20 and y1. Okay, so what I want you to do now is to go ahead to your window, and we need to change our y maximum. Currently, our y maximum is at 10, and we need it to be at 20 at least. Maybe we'll go up a little bit higher. Let's go up to like 25. Okay, so now we hit our y maximum, so the maximum on our y-axis to 25. That's all we changed, and we're going to hit graph one more time, and now we can see our first equation, negative x plus 20. Now, we still have a problem because we can see they're going to intersect, but that intersection is way out here, okay? If you've graphed it on your paper, you may already see what that intersection is, but if you haven't graphed it on your paper, we're going to have to figure out where that intersection is. So we're going to need to change the window one more time. So let's go out to this. That has to do with our x-axis. Let me talk to you about why that's our x-axis. If you look right here, we know it's further out over here. This only goes out to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need to go out further to see where this intersection is. So that has to do with our, not our x minimum, that has to do with our x maximum. So let's just try 20. Let's see if going out to 20 will allow us to see our intersection. Okay. Do we see it? Yes, we do. Now we can see it, so now we can calculate it. I don't know if you see right above this trace right here, it says calc. That means calculate. So because it's in blue, I'm going to have to hit my second button. Then I'm going to hit trace. And if you look right here at number 5 says intersection. Hit number 5. It's going to say first curve. Basically, it says, do you want us to look at the intersection between the first line? Yes. So hit enter. Then the second curve, yes. Second line, please look at the intersection between those two and guess. The calculator is not making a guess. It's actually calculating it for you, so hit enter one more time. So you will hit it 3 times. And how you know you're done is it should say intersection at the bottom of the screen right here. And so that means that our order pair, that our answer is 12 and 8. That means that 12 and 8 is the solution to this system. So if we go back to our notes now, let's add that in, please. Okay, so where it says solution, let's write that as an ordered pair, and then let's talk about what that means. Okay, so 12 was our x value, I believe, right? And and was it 8 was our y value? Okay, so what that means is that these are the two numbers that work for our two equations. So if we go back to our two equations, the first one was x plus y equals 20, and the other one was x minus y equals 4. Okay, so let's go up here and make sure those work. Is 12 plus 8 equal to 20? Okay, is 12 plus 8 equal to 20? Well, yes it is. So we know what answer is the solution to that first equation, but in order for it to be an answer to both of them, we got to double check and make sure it works for the other one as well. So x is 12. It says to subtract y, which is 8. Is 12 minus 8 equal to 4? Sure is. So that means that we have found the correct solution to this system of equations, and we are done. We can say that the answers are 12 and 8. Now, some of you might say, oh, we could have figured that out without having to do all that work. You're right, you could have. But we're going to be exploring more complex systems very soon, starting here in just a little bit, looking at number 2 and number 3. And so I'm going to need for you to start setting up equations using two different variables. So if we have two different variables, we should have two equations. And just a reminder that the solution to a system with two equations is going to be their point of intersection. It's going to be their point of intersection. So I hope this helps get started with the sheet that you have. What I'd like for you to do now is to focus on number 2 and 3, and see how you do, and we'll go over those shortly.